Hello everyone. Again in the new video, here I am going to just tell another example in which I am taking a question that is from the book of BALAGURUSAMY, and from the chapter 1 I have taken a seventh question, that is how are data and function organization in an object oriented program, and how are the data, that means how they are organized. So basically we are going to answer it. So first is, in object-oriented programming, O, data and functions are tightly bundled together into units called objects, which are instances of classes. So firstly, what is the data? Data means the variables that are stores the state of information of an object. They are also called data members, attributes, or fields. Example is such that here in speed, or in which we see that a variable integer that is holding the speed stores the information about the object. So it is data here. And the other one is function. So what is the function here? Function means the operation or actions performed on the data. In O, they are called member function or methods as well. Example is void accelerate. Here we have function, so we are taking the parameters. Then curly bracket, then a speed plus equals to 10. And here accelerate, change the value of a speed, so it is a function method. So let's see in the next. That is, we are saying an example in which this is in example in C++. So hatching to the extent using the message, especially study. You are taking a class name is car, and we have taken a private int speed, that is the data member here, and public void accelerate, that is the member function here, and we are just a speed plus equals to 10. So and to get this value, we are taking int get speed, where we return the speed, and we are recalling it in the main function, that is int main, and in the we are accelerating object, then we're calling it. So in the cout section, we are calling that is get speed with the object mica, and here what will be written. So let's see it in the VS Code. So let's see. So here we are in the VS Code. So we have the given example where we see here is the data member, the member function, and to get the value we taking from the private section, private to, then we are then getting it in the public, and to get this value we are getting the get spread function, and we are calling it. So this is all the way we are organizing the data and the functions in our uh, code. So on running it, we're going to see what we are going to get. We are going to get here 10, and also if you do not initialize it, we are going to get any random value, since we don't know the what is going to be our value. So let's see it also. So here it is. On slicing, we are going to get some random value, since we don't know that what is the value here. So again, we are going to initialize it 0. Uh, so now we will get 10, since the value initial value is 0 here. So after increment, we will get to see that we have increased it to 10. So now back to the question. Here what did we see? Uh, Nextly, we are going to see that who structure this, the classes and the object. So we are here in the C, in the class section, we see class is a blueprint or template that defines the structure of a object. It contains data members, store the state of the object. So basically, it store the all things in the class, and in the class we have the data members and the member function as well. Define the behavior of the object and operates on data. In the object section, we see that object is a runtime instance of class. It encapsulates both data and behavior as well. Since we see that in the previous question that it could encapsulate since we have the attributes and uh, we have given the we can initialize it in private section and as well as the if our data is in the private we cannot access it but we can but its own members could access it such as the public. So so the main idea was to encapsulate both data and behavior. And here example idea we can class could be a recipe or the actual distributor using the recipe. And in encapsulation section we see basically binding data and behavior. Data members are usually private or protected. So we can take it as private or private since we already see that we have taken it our data member is private in the first section and then in public where here we are taking a member function which is public and it is able to since we are in the same class we can able to access it and then to x after accessing to get this value we are taking another get aspect. So so it was all that. So they can not be accessed directly from outside the object. So that's why we are using the same class and its member. So member function provide a public interface to interact with the data safely. This mechanism is called data hiding, which protects internal details from external interface. And the next one is object behavior interface. Uh, so object interface interact with each other by calling public methods of other objects. They do not need to know the internal structure of the of other objects following the interface. Example idea is in the Java section we say my car into my car equals to new car. Just call it and call we are calling the class my car dot accelerate. Then system dot print my car dot get to speed. Here object data is accessed through methods not directly. See the method. Method is what was the method there? Get speed was the our method. So the next one is inheritance and polymorphism, where we see inheritance. That inheritance does allow one class to inherit properties and methods from other classes, enabling code reuse and hierarchical relationships as well. And in polymorphism, we see it allows different classes to respond to the same method call in different ways, providing flexibility in program. Here we have an example where that package is not the part of this, so you can slice whatever you want as your package. So I'm taking a Java example in which we see public class inheritance and polymorphism. That is the class name, a static class vehicle, and here's we have a class that is vehicle here, and we are extending it in the bike. So that is extending here, so as inheritance, and the white start here. Uh, we are taking it as polymorphism. So we are taking in the child class as well. So when we will call it, the both will be called. So here system.println bike is starting and vehicle is starting. The both must. If we will call this one just void start, this must be a start as the output must be just bike starting. But in the main section, we are going to public static void main. Here, you are just making a class object. Then, if you are calling v dot start, when we are going to get just this one. Then, but for the offer case, for uh, for our base class, that is bike. Here, state here it is. So when we call this v dot start, we are going to get. So firstly, this is a bit of confusion. So let's see it in the our Eclipse. So let's go to the actually here on taking the V data start. The first one vehicle starting will be there, and B data start bike starting will be there. And now going into the Eclipse, here it is. We have taken and we are in the Eclipse ID. So here we are seeing it package random. So we are taking class, and so if you are going to see, firstly just run it so that we will see what we are going to get. So here vehicle starting and bike starting both are the results we are going to get here. So as we have just written our code in the void start, and void start in first one is the base case, and then we are extending the base case. So we are taking the vehicle, we new circle, we are taking the vehicle, since we are taking this vehicle is our base case, base class. So base, it will recall basically your uh, means it will call your base members or whatever is available in the. So here in our base function, this will call our base function b dot start. Start is our function here in the base class. And since if you directly call the just our child class, since we have make the child object here to recall this b dot start, this will just call by starting. So if you just want to call the void start and making object with your by means child, so then it will call just your child members or child function. So that was all about the both inheritance and polymorphism. So let's go back to the our question. So in the final section, I'm going to uh, just explain the summary, in which what is the role in organizing. So first one is the class, in which we define structure and behaviors. In object, we encapsulate data and function. In encapsulation, we protect data and exposure behavior through methods. And in the inheritance, we share structures and behavior across classes. In polymorphism, enable flexible method behaviors. So that was all about showing you how does the data and function organizers in the object-oriented programming. So object-oriented programming, in object-oriented programming, data and function. Since we firstly see that what is data and function, how is data and function are just just like a blueprint, or you consider this a syntax like a structure. I have shown this in an example, and then in classes how we arrange it or organize it, and then inheritance and polymorphism as an encapsulation. How did we see and how do we just organize it, and then in inheritance polymorphism we have just shown it. How can you do? And that is all here. So thank you.